Hello and welcome to Tribe Topper. In this video session, you are going to learn about moving in a circle, where we are going to discuss the important parameters in circular motion. The first thing that you need to understand is angular displacement. Like in linear motion, you learned that if an object moves from one position to another position, say from the origin, this was x1 and this was x2, then displacement, the linear displacement is x2 minus x1. But in case of circular motion, it is the angle that an arc will trace out will be the angular displacement. So the definition is the angle moved around the circle by an object from where its circular motion starts is known as the angular displacement. Like if I say I have this arc, in the figure it is marked S, that is the arc length. S is the arc length. If we have traced out this much of arc starting from A and stopped at B, then this arc along with the radius has traced out an angle theta at the center. So R is your radius and theta is the angle traced out, which we call as the angular displacement. And in mathematics, in geometry, you have learnt this in junior classes, that how are these three things related? That angle is equal to arc length upon the radius. You can always rearrange the terms to find out any of the variables, but angular displacement is S by R, the length of arc divided by the radius. The second thing that you need to understand is what is angular speed. So just like we have linear speed, which is distance traveled or linear distance traveled over time taken, similarly you have angular speed, which says the ratio of angular displacement to the total time. That is called angular speed. So if I have to write, we denote it by omega. So omega is equal to, the angular speed is equal to the angular displacement theta upon the total time taken t, right? And its unit would be radians per second. Another thing that we need to know here is time period. Time period is very important. It's the time taken to complete one circle. That is called the time period. We always denote it as capital T. Do not mix it with small t, because small t represents any instant, but capital T always represents the time period of a circle or a revolution or an oscillation. So here we are talking of one full circle. So you start from here, complete a circle, that takes a time t seconds, then that is the time period. Now, I just told you that angular speed is theta by t. So I want to tell you here that if your t is not any time but it is equal to the time period capital T, then what should be the angle traced out? Obviously, it would be 2 pi, because time period is that time t in which your full circle is traced out. And angle in a circle, in a complete circle, is 2 pi. So we get theta is equal to 2 pi. Therefore, the expression becomes omega is equal to 2 pi by t. And this is the standard relation that is often used. So this is a very, very important relation. We got it from omega is theta by t, but we say when t is capital T, then theta is 2 pi. So omega is equal to 2 pi by t. Number 4 you need to know is frequency. So frequency would mean like how many circles you can complete in 1 second, or how many revolutions you can complete in 1 second. In 1 second. That is called frequency. So the definition, I'll repeat, the number of circles or revolutions completed per second is called frequency. And we denote it as F, and F is equal to 1 over T. Now, how do I get that? See, we say that in t seconds, the number of oscillations is 1. Therefore, in 1 second, the number of oscillations would be 1 by t. And we say that this number of oscillations in 1 second, which is 1 by t, is actually the frequency. Therefore, f is equal to 1 by t. And it's very obvious they'll be inversely related. If it takes more time to complete one revolutions, you will obviously have lesser number of revolutions per second. And the unit of frequency is hertz, while that of time period is obviously seconds. Since we learnt about linear speed earlier and now we have learnt about angular speed, we should know what is the relation between the two. See, when anything is moving in a circular path, it has both the speeds. One is the linear speed, which is always acting along the tangent like this. So your linear speed v is directed this way, and the angular speed is obviously based on the angle traced out. Now we know that v, the linear speed, would mean that the entire circumference, in how much time you cover the entire circumference. So that will be, v will be the length of the arc upon the time. And if I say again that t is not any time but time period, then S, the arc length, is going to be the entire circumference of the circle, 2 pi r. So in one time period, full revolution completed, and the length of arc traced out is the circumference. So linear speed is 2 pi r by t. Now, what is 2 pi by t? We just learned that 2 pi by t is omega. Therefore, what is v equal to? That's omega times r. So this relation is important. Or sometimes you have to use omega, then that is v by r. This is how your linear speed and angular speeds are related. So that's all for this video session. In the next video session, you are going to learn about the centripetal force and centripetal acceleration. Thank you.